convert denary numbers into hexadecimal numbers, I'm going to start with our place values. So, like all number systems, our first place value column is always the ones. In hexadecimal we have 16 different symbols for numbers, so 1 times 16 is going to be 16. Our next place value will be 16 times bigger, which gives us 256, and our next place value will be 16 times bigger to give us 4096. Initially, with hexadecimal, the numbers are exactly the same as they are in denary, or decimal system. So at this point though, we don't need to go into two place values as we would with our normal numbers, because we've got the additional symbols A, B, C, D, E and F. Just scroll that slightly there. Yep. So now this place value is full. We can't go any higher than F. So to get 16 we go into our next place value. So 16 is 116 and we need 0 ones. So to get to 17 it's 116 and 1 1. 18 is 116 and 2 ones. Now this will continue until we get to 31. So we've got our 1F. If we want to go higher than that, so for example to 32, then we would need a new place to change the second place value there. So we'd have 2 and the F would go back to 0, and that makes sense because 16 times 2 is 32. So let's have a look at some other numbers here then. So if we go with say 46, okay. Now the easiest thing to do with this then now is to actually get a calculator and use this for the maths part. So we'll bring the calculator in here. So what we need to do is think which is the biggest place value which will fit into 46. So it's not 256, it is going to be 16. But then how many of those will actually fit into 16? So let's do that. So we'll go, sorry, how many 16s will fit into 46? So if we do 46, we'll divide that by our 16s. So we're getting 2 16s there. So we'll put the 2 in there. So the next thing that I would do on the calculator, clear that one, and let's go, if we need to do, let's do 2 times 16, which is going to give us our 32. Okay, let's just remember that one. So I'll put that in the memory. And then let's go back to our 46. 46 minus, let's recall from the memory, that 32, and that leaves us with 14. Well, we know that we can count up to 14 with a single figure in hexadecimal, which is E. So we're going to put in our E there to make up our 46. So let's just try a different number. So I'm going to go with 255 because this is actually a special case in computing. So for 255, let's use the same method that we used before. So we'll get our calculator, we'll clear the memory in both of those. So we're going to have a look there. We can't fit 256 into there, so it's the 16s again. So we'll go 255 divided by 16, and that's given us 15. Now if we scroll back up again, we know that 15 is our largest single digit number there. So back on this one then we can put an F in there. Let's go back to our calculator, so we will clear that one then. So let's do 16 times 15 is 240. Let's pop that into the memory for the time being. So 255, take away the 240 that we've just got, which leaves us with another 15, so we can put F in there. So FF is the hexadecimal number for 255, and that's used in RGB colour codes as well. The other way of looking at this, which we could have done without really going through all the calculations, is 255, well, it's one less than that place value. So that means that these columns must be full. They must be as high as they possibly can be, which will be FF. Because now our next case, if we want to go to 256, these can't be any higher, so we go to a new place value, and these become zeros.